Hello everyone, myself Krutika studying in Sri Venkateswara College of Engineering in Department of Electronics and Communication. Today I am here to discuss about data flow diagram of ARM processor with example. Now let us discuss about introduction of ARM processor data flow diagram. So here you can see ARM processor data flow diagram. So first let us discuss about this diagram. The ARM processor is a popular type of microprocessor architecture used in many electronic devices. The ARM stands for Advanced RISC Machine. Overview of ARM processor components. The ARM processor consists of several key components. Those are registers, ALU, arithmetic logic unit, control unit, and memory. Data flow diagram components. The data flow diagram of an ARM processor typically includes components such as input, output, memory, registers, and arithmetic logic unit. Input or output in ARM processor. So now let us see what input and output does in ARM processor. Input or output operations involve transferring data between ARM processor and external devices. So here we can see the pictorial representation of application of input and output in ARM processor. Memory in ARM processor. Let us see what memory does in ARM processor. Memory stores data and instructions that the processor needs to access during operation. Registers in ARM processor. Registers are small, high-speed storage locations within the processor used to store temporary data. So in picture you can see there are many number of registers, user codes and user modes. Arithmetic logic unit in ARM processor. The ALU performs arithmetic and logic operations on data within the processor. And you can see the pictorial representation of ALU in ARM processor. Control unit in ARM processor. The control unit manages the flow of data and instructions within the processor. Let us see some examples of data flow diagrams. That is instruction fetch. During the instruction fetch phase, the control unit retrieves the next instruction from the memory. The MAR and sends a read command on the control bus. In response to the read command, the memory returns the data stored at the memory location indicates the PC on a data bus. Next, let us see instruction decode. In the instruction decode phase, the control unit interrupts the fetched instruction and determines the operation to be performed. The instruction decode unit is a part of the instruction fetch and decode cycle that helps and translates the instruction and fetches registers operand using the register set identifier. Operand fetch. Operand fetch involves retrieving data from memory or registers required for executing the instruction. The operand fetch or address computation stage gathers the operands of the instruction from registers and for memory reference instructions computes the effective memory address. Execution. Execution is the process by which a computer or virtual machine reads and acts on the instructions of a computer program. During the execution phase, the ALU performs the specific operation on the operands, and you can see here the machine cycle of execution. In step 1, it fetches the instruction from main memory, and in step 2, it decodes instruction into commands, and then in step 3, it executes all the commands by arithmetic logic unit, and in step 4, it stores the results in main memory. Result write back. After execution, the result is written back to memory or a register, depending on the instruction. Write back is a technique used to get data between the local processor or central processing unit and the final storage location, which is typically either main memory RAM or disk. Branching. Branching involves changing the sequence of instructions based on a condition or jump instruction. Branching is used in version control and software management to maintain stability while isolating changes are made to code. Interrupt handling. Interrupts are signals that temporarily suspend the normal execution of a program to handle an event. An interrupt tells the CPU that the device needs attention and that the CPU should stop any current activity and respond to the device. It is called interrupt handling. Data transfer. Data transfer involves moving data between registers, memory, and input or output devices. Here you can see how data transfer works in this pictorial representation. Benefits of understanding ARM processor data flow. Understanding the data flow within the ARM processor helps optimize performance, efficiency, integrated security, high performance and energy efficiency, large ecosystem for global support, and pervasive across markets and locations. In conclusion, the data flow diagram of an ARM processor provides visual representation of how data moves within the processor during operation. Thank you for watching this video. If you like the video, please like, share and subscribe my YouTube channel. Thank you.